In the previous video, we discussed the inclusion-exclusion principle for a two-set system. I'm going to teach you this principle for a three-set system as quick as possible. The principle for the three-set system is similar to the two-set system, which was in my previous video, and I've linked that below. That video is quick and is about 2 minutes 30 seconds long. For the three-set system, let's try to visualize it by drawing three sets. We will give the sets names capital A, B, and C. The inclusion-exclusion principle for a three-set system is the cardinality or size of A union B union C. The formula is given in orange. So how do we understand this formula intuitively? Well, the part that says A union B union C is all the elements of A, B, and C. The cardinality of this, which is represented by those two straight lines, is just the size or the number of elements in A, B, and C. So then this formula makes sense. The number of elements in A, B, and C is just the number of elements in A plus the elements in B plus the number of elements in C. However, that's just half the formula. Where do these terms come from? Let's say I have the set with these elements inside, where one is repeated twice. In a set, a repeated element is counted as a single element, so the set only contains elements 1 and 2. Because of this rule, a problem arises at the intersections of these circles. When I look at the cardinality of A, which is the number of elements in A, then any elements of A in the intersection point is counted once. Then, when I look at the cardinality of B, I've counted all the elements in the intersection point twice. Just to clarify, the intersection point is where the sets share common elements. When we count the cardinality of C, we have potentially counted any of its common elements a third time. So to factor in any of its repeated common elements, we remove A intersect B, B intersect C, and A intersect C. This works because these are all the common elements. However, doing this, any elements that A intersect B intersect C share has been removed 3 times. So to factor that in, we add A intersect B intersect C back. Let's verify the principle and then do the practical example from the last video. All common elements of capital A, B, and C are underlined by orange. To visually verify the cardinality of A union B union C, we need to count all of the elements in capital A, capital B, capital C, treating all repeated elements as single elements. In this case, the cardinality is 10. This time let's use the formula. The cardinality of A is 5, B is also 5, C is 8. The cardinality of the other terms are now demonstrated. Plugging these numbers into the formula gives you the cardinality of 10. Let's answer this question from the last video. The formula for the inclusion-exclusion principle is given below. We need to find out how many people took the survey given the information above. The information highlighted in blue are sets because they're a well-defined collection of objects. The information in yellow gives you the relationships between these sets. Let's have the set capital A represent automobiles, capital B represent bus, and capital C represent trains. We already know the cardinality of A, B, and C because we know 30 people took the bus, 35 people took the train, and 100 people took the automobile. The rest of the information is about the relationships. 15 people ticked bus and train, so that's B intersect C. Another 15 ticked both bus and automobile, which is B intersect A. 20 people selected trains and automobiles, which is C intersect A. And 5 people chose all 3 methods of transportation, which is the final term in the equation. Running this through the calculator gives you the cardinality of A union B union C being 120, which is how many people that took the survey. Alright everyone, thank you for watching. Join me next time where I'm going to try to give you an unconventional way of understanding adding, subtracting, dividing, and multiplying so that it's easier to understand in fields such as engineering, physics, and electronics. Also, if you haven't already, check out my posts on my website, which is linked below, and that's all about suicide ideation and how to deal with intense emotions, amongst other mental issues. I intend to keep improving my content, so don't forget to subscribe because your support is what makes this channel real.